Alrighty then, we are in day 2 of graphing the hyperbola. Okay, so the hyperbola, the equation itself looks very much like the ellipse. Okay, matter of fact, they're identical except for the negative sign. But there's some rules that are a little bit different. For instance, this first one we're dealing with, how do we know if we have a vertical or a horizontal hyperbola? Where in an ellipse, the bigger denominator would tell us which one's A and which one was our major axis. In hyperbola, it actually deals with x and y. So in this case, since x squared comes first, it's a positive one. This is a horizontal hyperbola. Okay, so we're going to be dealing with all of our equations based on that. So first thing we're going to do is find the center. So just like the ellipse, this is h, this is k. So our center is at -5, +4. Now in the hyperbola, a is always the first denominator, the positive one. So a is 3 and b is 1. And then to find c, it's the square root of a squared plus b squared. So in this case, the square root of 10. Okay? So now that we know a, b, and c, we can find all of our other information. Since this is horizontal transverse axis, our vertices are going to be -5 plus or minus 3, 4. Oh, those are our vertices, not our foci. Sorry. -5 plus or minus 3, 4. Our foci are going to be -5 plus or minus the square root of 10, because it's c. And then we don't have co-vertices, but we do have our asymptote equation. Okay, so our asymptotes. It's going to be y equals, and you go to the equation, it's k, which in this case is 4, plus or minus b over a, so 1 over 3, x minus h, so plus 5. So that is all of our information that we need to find. Okay, and now that we have that information, we can graph it. So, just like before, we start with our center. So -5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay. Our vertices are going to be 3 to the left and 3 to the right. So 1, 2, 3. This is the vertices. So the center. 2, 3. This is my vertices. There. My foci are going to be 3 and a little bit, so they're going to be right outside. Right here and right here. Those are my focal points. Now, to draw the rest of it, we're going to use the idea of co-vertices. So b is 1, so I'm going to go up 1 and down 1. Okay? Now, I'm going to use these 4 points that are technically our vertices and where our co-vertices would be to create a kind of rectangle. Okay? So this rectangle basically shows me how my asymptote should look for my hyperbola. So you start at the corner and draw a diagonal through your center like this, and that'll give you your asymptote that we're going to use. Okay, and do the same thing the other side. You could also use a slope. Rise is 1 over 3, so up 1 over 3, up 1 over 3, and that'll also give you that same line. Okay? And then you can do the same thing down 3, 1, 3, 3, 1, 3. If you want to do it that way, if you want to be absolutely and more precise, you can do it that way. And those are your asymptotes. Okay? Then graph your hyperbola. You start at the vertex, and then it just follows your asymptote out. Like that. Starts here, and it goes out. Like that. That's basically all there is to graphing the hyperbola. Okay? Alright, let's try one more. Okay? So again, we have this equation. Looks very similar to our ellipse. First thing we have to figure out, just like the ellipse, is are we dealing with a vertical or a horizontal hyperbola? Well, again, if this were an ellipse, we look for the bigger number in the denominator, but since it's a hyperbola, we look for which one is first. Since y squared is our positive term, which comes first, this is a vertical one. Okay? So this is a vertical hyperbola. Or if you're from West Texas, you could say hyperbola. Okay, so same thing, find the center. Now this is the part that sometimes we mess up. Since x is second, sometimes we switch our h and k, but remember, h is still the one with the x. So our center is at 2, in this case, 2, 6. Okay? Our foci, since A is 3 and B is 5, C is going to be the square root of 9 plus 25, which is the square root of 34. So our foci are going to be at 2, 6 plus or minus the square root of 34. Our vertices are going to be at 2, 6 plus or minus 3. And then my co-vertices, my asymptotes, the equations, are y equals 6 plus or minus, it's a over b, so 3 over 5, x minus 2. Okay? So there's all of our information. And we do it the same way. Start from the center. 2, 6. 2, 1, 2, 3, 4, 5, 6. So that's the center. The vertices this time are going to be up and down. So we're going to go up 3, 1, 2, 3. Down 3, 1, 2, 3. Those are my vertices. Vertices, vertices. My focus, square root of 34 is almost 6, so it's between 5 and 6. So we go up 1, 2, 3, 4, 5 and a little bit. So focus here. 1, 2, 3, 4, right there. Focus. That should be a little bit further down here. Okay. And then again, we're going to use that idea of our co-vertices. So we're going to use B to go out the other direction, perpendicular. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And use these points to draw that rectangle to help us graph. So this is going to be our rectangle. And you can see that it does use a slope. We go 1, 2, 3, 5. It'd be here. But if you want to, we can use this box to draw these asymptotes. Like that. And again, to draw the curves, you start at the vertices, and then you follow the asymptotes. Okay. For my students, you need a code T3ST1NG question mark. T3ST1NG question mark. Now, I do want to show you guys something just so that you can see it. These two practice problems are actually very similar to the ellipse problems that we just did. Okay? If I just take this equation and change this to positive, basically this rectangle that we just drew, the ellipse actually shows up inside. The inside of the rectangle actually creates the ellipse, where the outside rectangle represents the hyperbola. Because the ellipse is the sum of the distances, and the hyperbola is the difference of the distances. So they actually, if you can draw an ellipse or a hyperbola, you can draw the other one. Okay?